Hello class, and welcome to today's algebra lesson, which is about adding and subtracting polynomials. By the end of today's lesson, you will be able to identify polynomials and their degree. You will be able to write them in standard form and find the leading coefficient, and you will be able to add and subtract polynomials. So we're going to start with what is a monomial. There's going to be a lot of vocab here at the beginning so that we can apply these things to the rest of the lesson. So a monomial is a number, a variable, or the product of a number and variables with whole number exponents. So, for example, it could be just the number 5, or it could be the letter x as our variable, or it could be 6ab to the second c to the third, where we've got a number and variables being multiplied. Notice all of the exponents here are positive. In order for it to be a monomial, it cannot have negative exponents, which means that there cannot be any variables in the denominator. So if it was a fraction, let's say x over 2, that's okay because it is a number, a constant value in the bottom. If we had the opposite, x over 2, remember that that means that we've got x to the negative first power because that variable is in the denominator. So again, number, variable, or the product of numbers and variables. If it's just a number, so for example 5, we call it a constant. That's a specific type of monomial. When we expand into polynomials, this is where we can start bringing in adding and subtracting. So a polynomial is a single monomial, so it could be just a monomial, or it can be the sum or difference of 2 monomials or 3 monomials or 7 monomials being added. If it's just 2, we specifically call it a binomial, so there's 2 parts, so it could be 2x plus 7y, or it could be 8y to the third minus 9, are both examples of binomials. There's 2 parts to the problem. A trinomial then is when there is 3 parts. So for example, 5x squared minus 9x plus 14, or something like negative 6y to the 7th minus 8x plus 3 could also be a trinomial. So there's 3 different pieces. Polynomials are written in standard form when the highest degree, so the biggest exponents, come first. When we are talking about those exponents, we have to look at the degree of each monomial first. So, for example, when I gave you the negative 6y minus 8x plus 3, if we look at our exponents, I've got 7, and then the x has an exponent of 1, and then the 3, if it's a number, we put an exponent of 0 on it when we're talking about degree. So it's not actually to the 0 power, but it's a 0 degree because it does not have a variable with it. The degree of a polynomial then is the highest degree of a monomial. So this one we've got negative 6y to the 7th, so this would be a 7th degree trinomial. The leading coefficient then is the first number when it is written in standard form. So in that case, it would be negative 6. So let's go through and do a few examples here. The first one, we've got 4y minus 5xz. So yes, this is a polynomial. It meets our rules of being a monomial or the adding and subtracting of a monomial. Our degree, in this first one, I've got 1. In the second term, or the second part of my binomial, I've got 1 and 1, giving me a final degree of 2, because the first degree is 1 and the second degree is 2. So the second is bigger. And then it is a binomial because it is 2 parts. If I look at part B, Once again, yes, it is a polynomial. It is a 0-degree polynomial because it is just a number. And then since it is just one singular number, it is a monomial. It is one thing by itself. When I come down to this next one, notice we've got a negative exponent, which means that the first part is not a monomial, which means that the whole thing is not a polynomial. You can't do anything else if you have negative exponents or variables in the denominator. For this last example, once again, we've got different pieces. All of the exponents are okay, so this is yes. When I add up those exponents, the degree of the first term is 4, the degree of the second term is 2, the degree of this third term is 1, and then the degree of the last term is 0. So our biggest number here is 4. So we've got a 4th degree. And then since this one has 4 parts, we just call it a polynomial. The only ones that have special names are monomial for 1, binomial for 2, and trinomial for 3. Go ahead and try this first example on your own. So it is yes. We have a 3rd degree because our highest exponent is 3, and then a trinomial because there is 3 parts. Go ahead and try part F on your own. Once again, this is a yes. When I look at my exponents, I've got 1 and 4, which gives me 5 as my highest degree, and then it is a binomial because there are only 2 pieces. Once we know how to identify the polynomials, then we want to start to be able to put them into standard form. Remember, standard form means the highest degree term shows up first. So I start looking at this first term. I've got 5x, that's to the first power, which means it's the first degree. My second term, I've got negative 9xy, so that's 2 exponents of 1, giving me a degree of 2. Then I've got minus y to the 4th, 1 singular exponent of 4. And then I've got minus 6y to the 3rd, 1 single exponent of 3. So I need to put this in the order now from least to greatest. So my first term is going to be negative 2y to the 4th. Then after that, I've got negative 6y to the 3rd. Then I've got negative 9xy. And then I have positive 5x. Notice, whatever value is in front, so positive or negative, moves with each term as it goes. So the negative in front of the 9 stayed with the 9. The negative in front of the 2 stayed with the 2. The negative in front of the 6 stayed with the 6. And the 5 was positive, so it was plus 5. So this is writing our polynomial in standard form. The other piece is to identify the leading coefficient, and that is the front number in standard form. So in this case, it is negative 2. Go ahead and try this one on your own, first writing it in standard form, and then identifying the leading coefficient. So we've got negative 24y to the 7th, 8y to the 5th, minus 19, giving us a leading coefficient of negative 24. When we are manipulating these polynomials, we also want to be able to add and subtract them. When you add and subtract, it's just like adding and subtracting any other variables. They must match exactly in order for you to add them. So when I'm going through this problem, I'm going to start by looking at my first term. I've got 2x to the second power. I look across all of my other options and I see if there are any other x to the second powers. In this case, we've got a negative 4. So I'm going to have 2x squared plus negative 4, plus a negative turns into just subtracting, which gives me negative 2x squared. Then I'm going to move on to my next part, which is 5xy. I check out the rest of my equation, and I see I have a plus 6xy. So 5xy plus 6xy gives me 11xy. Moving on to the next term, I've got negative 7y, and then I have plus 3y, which is going to give me negative 4y. And then I have this 5x all by itself at the end. That can't be combined with anything else, so it just stays as 5x. Now I need to make sure that I am writing this in standard form. So I'm going to look at my degrees, and I've got 2, 2, 1, and 1. So when you put this in order, I'm going to have negative 2x squared plus 11xy minus 4y plus 5x. When you are arranging in standard form, if they have matching degrees, you can go ahead and put them in either order. So you also could have written this final answer as 11xy minus 2x squared plus 5x minus 4y, or any other combination that keeps the degrees in the correct order. Go ahead and try this one on your own. So we added each of our different pieces to give us a final answer of 3y squared, or excuse me, 3y to the third plus 4y squared minus y plus 3. If you said minus 1y, that is also okay. Same idea is going to apply if we are subtracting our polynomials. Once again, we want to go through and identify each separate piece. So I'm going to start with 8ab. There is another ab in the problem, so I have 8ab minus a positive, which is just subtracting 12ab, giving me negative 4ab. Then I go through and my next piece is negative 10. There is another constant in the problem, so I've got negative 10 minus 7, giving me negative 17. Then I've got 5b squared. There is no other b squares in the problem, so 5b squared is going to stay put. And that leaves me then with subtracting a negative. So nothing minus a negative is going to give me a positive b to the third. Once again, going through, looking at our degree, I have a second power, a 0 power, a second power, and a third power. So I'm going to start with b to the third, then I'm going to add on b squared. You could have subtracted 4ab first if you wanted to, because these two have the same degree, and then subtracting 17 has to come in last because that is our lowest degree. Go ahead and try this one on your own. So we subtract all of our pieces out, and I end up with negative a squared minus 6a plus 8. Again, if you want to have negative 1a squared in the front, that is fine. Last piece, we're going to wrap it up with a word problem. An electronics store is starting to track sales of cell phones and iPads. The equations below represent the number of cell phones, C, and the number of iPads, P, sold in M months. Find an equation for the total T for each month, and then calculate the total for 10 months. So our first job is to find the total. When we find the total, we are going to be adding. So I've got 4m plus 78, my first part, plus 7m plus 137 as the second part. When I go through and add, I'm going to start with 4m plus 7m, which is going to give me 11m. And then I've got 78 plus 137, which is going to give me an answer of plus 215. So that would be my equation of total equals 11m plus 215. Go ahead and find the total sales for 10 months on your own. So when you go through to find total sales, you're going to plug in the number of months, which in this case is 10. Then you would solve 11 times 10, which is 111, plus 215 is going to give you a total of 325 devices sold in the 10-month time frame. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.